how would you get started? First question is it too late? And should I get into this now? Have I missed the boat?
No, not at all. It's not too late. I think, I'll give you an example. I trained some large language models using an efficient technique just a few months ago.
Yeah.
Mostly just to learn how to do it because I didn't know how to do it. I don't use large language models most of the time. I use vision models.
Yeah.
And I thought, well, let's add another string to my bow or whatever the phrase is. And so I went off and I trained it. And it took me a few hours to kind of look through the code, work out what was going on, get something training. Yes, I have some expertise, but ultimately it's mostly just Python code, right? So actually, I think you can pick these things up pretty quickly. And the other thing is that the technology is moving unbelievably fast, and that's both good and bad, right? It can give you the impression that you're going to be left behind, but actually what it means is everyone's just having to relearn everything every 6 months anyway. It's a bit like JavaScript libraries, isn't it? So, in a way, I think that it's actually a benefit for people coming on board that a lot of what we're doing now isn't what we were doing 2 years ago, because it allows you to go, well, we'll just pick up what we're doing now and let's go with that.
So not too late, but what should I do then? What would you do now if you started again in 2025?
Yeah, so let's think about where people would be, right? So if you're an undergraduate and you've been working in the industry and you know how to code already, then the best thing you can do is take a very quick introductory machine learning course, get that done, and then just start playing around and trying these things out. Particularly with things like Google Colab, loads of big libraries that do things like retraining large language models, they come with Google Colab or other examples that you can literally just run. So the first time you run it, it's a complete black box to you. You don't know what's going on. You just click play and it runs and you're like, oh, I'm training something. This is great, And then you start to delve into it a bit and you slowly start to realize what's going on. You start opening that box. If you already know how to code, for example, in Python, then I think the best and quickest way is just to basically jump right in and start training some stuff up. Even though the first time you train it, you're going to feel out of your depth. You're going to feel like you don't know what's quite going on. And then over time, you will start to pick this up pretty quickly.
Do you have a course or do you recommend courses?
So I always still recommend Andrew Ng's Coursera course for machine learning, because I'm a sort of a firm believer in the idea that if you know how machine learning works, which is to say things like what does a learning rate do? What should a loss function do? Then the rest of it kind of comes out in the wash, right? Yeah. Large language models sound fancy, but they're just big versions of the kind of same networks that were being trained many years ago. And they train in exactly the same way, which is to say you have a loss and it goes down as you get better at predicting your outputs. And if you know how to interpret that, if you know how to look at those numbers and go, right, this is what I should do next, that's going to put you in a really good position. If you jump in and run the code, then you'll see this loss going down, and that's great. But then when it doesn't go down, you won't know quite what to do. And that's, I think, where a little bit of the fundamentals will help. Right? And you can do these things kind of at the same time. So, there are different levels of machine learning. So there's sort of what we will call maybe sort of standard machine learning or classical machine learning. These are things like support vector machines and small artificial neural networks. These are the kind of topics that are covered in things like Andrew Ng's Coursera course. And above them, you've got the kind of convolutional networks and the vision networks and then transformers. And then above there you've got the really big large language models. And they're a progression. If you understand what one does, it's a kind of a level of abstraction. You can understand what the next will do and what the next will do. And the leap isn't as big, going upwards. Almost all of my research is AI driven now. It's interesting. I do sometimes do traditional computer vision, which is to say, manipulate pixels basically. And I can still do that. And I sometimes force myself to do it just to remember how to do it. But actually, often, a lot of the time, someone will present me with a problem and my first response will be, well, we probably need to train a deep network to solve that problem. It's both true that we are in a hype cycle, but also true that these are incredibly performant techniques and knowing how to use them is going to help. Getting the first ones trained, that's not a big ask. It sounds really hard. It sounds intimidating, but I kind of feel like that's a bit gatekeeping, right? It's a bit people saying, this is super hard. Look how smart I am.
Yeah, exactly.
I don't like that approach, right? I prefer the approach of saying, look, they've developed these libraries to make them easier to use, specifically so that you can have a go and use them. Right? And then if you're willing to kind of get a little bit stuck in, one of the things that I did when I was learning how to train large language models was I looked at the data. I actually looked at the rows of data that were going into the model to see how they were structured, how they shaped that data that the large language model could use. And that allowed me to shape my own data to reflect that, and then I could train on my task. So a lot of the time you're kind of learning by seeing what's been done before and kind of manipulating that into something that works for you and then going again. And then once you know how to interpret the results, then you're all good.
I'm glad you mentioned gatekeeping, because it feels like unless I've got a PhD or I really know maths very well, or all this like data science stuff, I've got no hope.
I'm a firm believer in an undergraduate degree as well, right?
Yeah, sure.
But it serves a slightly different purpose. There are loads of benefits to going to a university to study computer science for 3 years, and that's all you study, because you learn a huge broad range of topics. AI is only a very small part of what you learn at an undergraduate degree. You'll also learn, how firewalls work, right? And how object-oriented programming is done. If you already know some of those things, then actually a degree is only going to have a very small part, right? Maybe a master's might be more targeted. But actually, I think that for people who know what they're doing, for people who've already got a degree, it isn't reasonable really for you to go back and pay again all those fees to learn a second time. That's when you use the skills you've got already. The fact that you know how to work independently, you can learn on your own, you're willing to have a go. Those things are going to help. And there's loads and loads of resources online.
So learn Python, that's the first step, right?
That's 100% the first step. For better or worse, Python has kind of emerged as the language of choice for most machine learning. That's true of pretty much most, any type of machine learning. Lots of people work in other languages like MATLAB and C and things like this. For the most part, people work in Python. All of the big libraries, so things like PyTorch, and large language model libraries like Unsloth that we can talk about later, those are all based around Python. They all operate in a similar way. And so you very quickly get used to how this works and the ins and outs. Learning Python is the first thing to do. And I would say also that Python has a lot of very advanced language features that hardly ever come up, right? You might see a function call that uses some strange Lambda expression you're not expecting.
Yeah.
But in general, that doesn't happen. And actually kind of standard Python will get you through most of the day.
So Python, then Andrew's course on Coursera, and then?
Yeah, so I mean, there are going to be lots of courses. So if you're on, a different platform like Udemy or something like that, there will be perfectly good introduction to machine learning courses. I would advocate not getting too overexcited and jumping straight to the large language model on day one, because if you do that, it will be a black box for you. It's going to be something where you're training or using a very, very large model that you don't understand. And that's fine. You can build a product based on that. It's what a lot of startups do.
Yep.
But you will be able to use it better if you have a little bit of an understanding of what's going on underneath. And to do that, you need to build up a little bit from the ground up. And it doesn't take that long. We have undergraduates who start projects and they haven't got any AI background particularly, and they're training things up within a few weeks, right? To the point where they actually know what's going on, right? It does require some effort. It's not something where you can just go on GitHub, go to the Colab, run it, and then consider that problem solved. You are going to have to look into these things.
Python, Andrew's course, or some other courses, anything after that? Do I need to buy books? Or
there are loads and loads of books on machine learning, and I wouldn't necessarily say that's a bad thing to do. I think one of the problems is because everything moves so quickly, those books, it's going to be difficult to have books that are on the cutting edge version of some library you're trying to use. And so I found my personal experiences of learning some of these techniques is just to run them. Like I say, the first time you run them, they're hard, and then they get a bit easier and they get a bit easier until, okay, this is pretty routine. Most of the big libraries have tutorials, and they're not all great, to be fair, so I think your mileage may vary. But I would say that the other thing you can do, and this is a bit like learning to code, right? If you want to learn to code, I've always thought that the best thing to do is just to do lots of coding, right? It's not something where, yes, you can be taught concepts, you can be taught, about conditions and Booleans and things like this. But ultimately, when you spend time just answering questions and solving problems using code, you get better and better at doing it. And I think that's very similar also with machine learning. If you train up a simple classifier and then you go on to a more complicated topic and so on and so forth, that's kind of a nice progression. So maybe we can talk a bit about that progression, right?
That'd be great, yeah.
If you do something like Andrew Ng's course, you'll find yourself, pretty well versed in kind of low-level standard machine learning, which is to say things like support vector machines and neural networks. The next thing perhaps to do would be to look into something like a convolutional neural network, or maybe a transformer, but they're a little bit of a step up, or at least they're a little bit different, conceptually different. There are, thousands of collabs or GitHubs that show you how to train a standard convolutional network from scratch. The PyTorch examples are perfectly good for doing this. You can just run them and they'll just classify some stuff and they'll download the data set for you. they'll classify some stuff and they'll learn, and you can sort of watch the numbers go down, and then you can go into the code and go, right, how did that actually happen? And then you can start to build up the complexity. If your aim is to go very much down the sort of modern generative AI route, so the kind of LLM route, then at some point you'll need to start making use of some of those tools. And so those would be things, libraries I quite like, so things like LangChain. So LangChain is good for putting models together into kind of working systems. And then you've got things like Unsloth, which is really good for fine-tuning large language models, which are pretty prohibitively costly to tune normally.
Yep.
And so, there's lots of these libraries, and they all come with, pretty good documentation and examples that you could actually run.
Do you have to pay a lot of money to run this stuff, or is a lot of it free?
No, you can. I think some of them have like a kind of commercial tier, but everything that I've used so far has been, either, free license. And I think that's fine. You can make a decision later whether something requires a little bit of payment. So, Google Colab is a good example, right? Google Colab runs essentially a Python notebook. A notebook, for those people who are not familiar with Python, is essentially, instead of having one code file, you have kind of blocks of code interspersed with images and text and other bits of information. They can be very useful for documenting, but also looking at the output as you go. And you can also run these things in different orders. So you can say, okay, I want to go back and run that bit, see what the output is, and then run something else and see what changes. Google Colab is that, but a little bit posher, shall we say, and also backed by Google's GPU environment. So you've basically got the ability to actually train models on these without it being really, really slow. If you want to do more than kind of token training, it's going to need you to pay some kind of £9 a month monthly fee. Else you're going to be waiting for a few hours for a GPU to free up, right? And so you can make that call at the time. Certainly, you don't need to pay to begin with. You can just get started, run a few things, try them out, see how you're getting on. And if you think, okay, I actually need to train this thing for a few days now to see whether it works, that's when you could consider investing in some resources.